Hey everybody, we're going to continue our work on the second session of the practice test for the MCAS. So if you look in the video description, you'll see a link to the Pearson website in which you can take this digitally. So the idea is that you take this digitally while also taking down notes in the PDF, which all my students should have, and the link to that PDF is also found in the video description. Okay, so let's take a look at this problem. Similar triangles RST and UVW are shown below. So here's RST and here's UVW. Okay. Based on the the dimensions in the diagram, what is the length in centimeters of VW? So we're looking for this, looking for the length of that in centimeters. All right. So VW is right here. All right. So we know they're similar. So there's going to be a proportionate relationship between these sides. So the ratio of one pair of sides should be equivalent to the ratio of the other pair of sides, so long as they correspond properly. Let's look at the similarity statement we have here. So RST and UVW. So VW are the last two letters. So that means ST should be the side that corresponds to it, which is right here. So we're going to call this X. So we'll have blue over red. So X over 5. Okay. And we have this side here. So UW is the first and last. So that means we look at the first and last letter over here, which is R and T, which is right here. So we're going to have 9 3/4 over 6 1/2. Okay? So setting up this proportion is really the hardest part of this. So knowing how to use the similarity statement to understand the order of the letters is important, because you'll notice these triangles are not oriented in the same way, so you have to be able to use this to find which sides match up with which sides match up with each other, essentially. All right, so to solve for x, we're just going to multiply both sides by 5. So let's do that. You could cross multiply, but there's really no need to. So let's do this. I guess we'll do this first and multiply by 5. So you can see this. Yeah, here you go. So 9 3/4 divided by 6 1/2. We get 1 1/2, then multiply that by 5. And you should get 7 1/2 centimeters. And this is part of the calculator section of the test. You'll have access to a calculator on your computer, on your screen. And again, you should be looking at this digitally to make sure that that's how you're going to be taking it. So the purpose of the PDF is just to have notes so you can go back and check before the test. So 7 1/2 centimeters. Okay. Next one, number 6. All right. Well, and just a quick aside back to this problem. This is a really good example of why you want to be using scrap paper, because you won't be able to draw, like this is going to be in front of you on a computer screen, right? So sketching this on a piece of scrap paper and being able to identify the sides is really useful. If you don't want to go through that trouble, I would at least write down the similarity statement, because trying to go just from the screen to the answer without writing any of this down is a surefire way to get this problem wrong. And you're going to hear me say that multiple times. Like, you need to be using the scrap paper. Unfortunately, the switch to digital format has taken away the ability to simply just write on the test. So we have to make do and improvise. So using scrap paper is really important. Okay. So don't just try to figure it out in your head. That's the worst possible thing you could do. All right. So here we go. This is really about function notation, if we have a firm understanding or not. Okay. So we have f of x equals x squared plus 1. It's asking us which of the following expressions is equivalent to f of m plus 2. So all we're doing is we're taking this m plus 2 and we're going to plug it in here and see what we get. Okay, so we're going to write f of m plus 2. And we're going to plug this in where the x is. So we're going to have parentheses m plus 2 squared plus 1. And now we have to be able to simplify that. So m plus 2 squared, right? So let's see. It's going to be m plus 2 times m plus 2 plus 1. Let's zoom in so you can see that a little better. Okay. So I'm going to distribute. So m times m is m squared. M times 2 is 2m. Now we're going to distribute this 2. So 2 times m is 2m, and 2 times 2 is 4. And now we're going to combine like terms, which is this and this. So bring down the m squared, and then 2m plus 2m is 4m, and then 4 plus 1 is 5. And that should be f of m plus 2 equals this. Alright, is that any of these? Yes it is. Let me zoom back out, sorry. Yep, it's going to be this bottom one right here. Okay, so for this one again, you want to be able to really use function notation, plug this in for x, and then you also need to be able to multiply a binomial by itself. So this is just, algebra. Hope that helps. Again, you'd want to write this down. Trying to do this without writing this down is a terrible, terrible, terrible idea. All right, number 7. So here we go. The circle is graphed in the coordinate plane. Okay, so we have a circle here. What is the radius in units of the circle? So for this particular example, we have to know what radius means. The radius is the distance from the center of the circle to any point on the circle itself. So the center of the circle, we can actually tell just by kind of checking this out. We know that right there, if we look, is the center, because like 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So you can graphically just find the center really quickly. You could take these 2 points and find the midpoint. There's really no need to do that. Just do a graphic. It's going to save you a bunch of time. So that's the center. What's the radius? So I can just count from the center to the edge. 1, 2, 3, 4. The distance is 4 units. That's the radius. Okay, pretty simple. So we need to understand what the center of a circle is, right? And you need to understand what the radius is. So yeah, again, you can find the midpoint here, and you could. There's really no need to. There's really no reason to. It's just adding more work for something you can do very quickly and efficiently. All right. Now this is something I expect students to have a hard time remembering. So this is why hopefully this problem will help a little bit, this review for this problem. What is the equation of the circle? Drag and drop a number into each box to correctly complete the equation. So you need to know what the base equation of a circle is, and that is not provided to you on, actually, I'm going to double check. I'm pretty sure it's not provided. Hold on. No, it's not. I didn't think so. So yeah, you have to know this equation to get this correct. I mean, you could guess, but that's not a great way to go about it. So the equation of a circle is going to be x minus h squared plus y minus k squared equals r squared. So hk are the coordinates to the center of the circle, okay, and r stands for the radius. Okay, so you need to know this base equation in order to do this. So the second part, like there's a lot of students, I guarantee you, in the state that did not get this correct, just because there's very few students just walk around remembering the formula to the equation of a circle. It's just not something a lot of people use oftentimes. So yeah. All right, so let's identify the center. We can figure out the h and k pretty quickly. So let's go back to the previous page here. So our center is going to be, let's see the coordinates. We're going to go 3, negative 5. So the center is 3, negative 5. So our h is 3 and our k is negative 5. Okay. So 3 would go here, right? And negative 5 would go here. Okay, so we're 2 out of 3. And then this is r squared. So our r, our radius, which we already found earlier, is 4 units. So what's 4 squared? Well, 4 squared is 16. So this would go here. Okay. So there's no real way to cheat this. You kind of have to understand that the center point is hk, that this is the center, these are the center coordinates. And if you know that, you're good. Basically, if you know this formula, you're good, right? But you need to know this formula. So this is something that you're going to want to commit to memory. If it comes down to knowing this or some other key points, I actually would, if you had to choose between, let's say, knowing this and how to, graph a linear equation, clearly you want to know that skill more than this, but it doesn't hurt to know this, especially since we know they're willing to test this. So, all right. And that was I didn't forget to number that one, sorry. That was number 7. Okay, number 8. Yes, number 8. Okay. Now, let's see. The number of customers doing business with a landscaping company each week over 2 weeks since the beginning of last summer can be modeled by this function. Okay, so this is a linear function. This is going to test our ability to interpret a linear function and really take information out of it. Okay, it's a little more abstract. Based on the function, which of the following statements is true? The number of customers increased by 21 per week. Well, no, because let's take a look at what we know. So we can always think of y equals mx plus b. Right. This is just in function notation format, but this is a linear equation. We know that the coefficient of x is going to be our rate of change, also known as the slope. But in this case, it's better off knowing its rate of change. Let's zoom in a little more here. Right. This is going to be our y-intercept, also known as our starting point. Starting point. For a lot of situations, Okay, so let's take a look at this. Well, our rate of change is right here. So every time a week goes by, this increases, and this is going up by 4. So this is definitely not it. The number of customers decreased by a factor of 4. Well, no, this is a positive 4. It's increasing by 4. The company began last summer with 21 customers. It's our y-intercept. It would make sense at 0 weeks you have 21 customers. That's looking pretty positive. And the company had a total of 21 customers after 4 weeks. No, it's definitely not the case. It's because you plug in 4 here, you're going to get 16. Add 16 to this, you're going to get, 37? So no. So just by process of elimination, you can see it's C. But, again, think of the y-intercept in a lot of these linear functions as the starting point. Because if your input is 0, right, if our x value, in this case is t, is really our x, if that's 0, what's our starting point? It's 21. Okay. They try to kind of screw with you guys because if you saw this in terms of x and y, like y equals 21 plus 4x, you're just used to seeing that, right? That's all this is. They just changed around. Instead of y, we have f of t, and instead of x, we have t, right? It's just function notation, but it's the same concept, right? So hopefully that explains that one. All right. This is number 9. All right. Let's see here. Oh yeah, this one's interesting. This one's very interesting. Let me go ahead and I want to bring up the digital format of this while I'm talking about this one because this one, okay. So a student plotted EF on a coordinate plane. The coordinates of the endpoints are shown. So here's E and F. So, the student will dilate EF by a scale factor of 2 with respect to point F. That's important. To create KL. Graph KL on the coordinate plane. All right, so when you're doing this problem, right, and you should be doing this digitally, or if you've already done it, hopefully, if you haven't done it, pause this, try it, then come back. Otherwise, this is kind of counterproductive. So you want to graph this, right? You want to graph EF. You want to graph that, and then you want to be able to graph the dilation. This is how we all learn how to dilate and graph and apply transformations. What we all want to do is be able to graph the pre-image and the image. Pearson, in their divine lack of wisdom, they make it so you can only graph one. You can only graph the image because why would we want to be able to do both when we all learn how to do it that way? But anyway, So you kind of have to know what you're doing here to a point where you can kind of ignore the way we've done it before, which is kind of silly. But anyway, I'm going to graph EF. Okay, even though you don't need to, but you kind of have to. You'll see. E is going to be negative 2, 1. So here's E. Right. And is that E? Yeah, let's make that a little more clearer. That's E. And then F is 1, negative 2. So 1, negative 2 is down here. Okay. So we're dilating with a scale factor of 2 with respect to point F. So from here, we're going to dilate it by 2. So let me go ahead and connect these. Now, we're dilating it by 2. In other words, this is going to get twice as large. Okay? So basically, if this was 2 or negative 2, it doesn't really matter. You take the absolute value of it, and that's the amount we're multiplying it by, essentially. So this distance is going to be multiplied by 2. So we can figure that out pretty quickly, right? So what I did when I took this digitally, I graphed this, and then I stretched it out to be twice as large with respect to point f, which means f is not going to move. F is going to stay right where it is. So what you're going to do is you're going to graph these 2 points, which you can all do, right? Scale factor 2, which means we're just doubling it, right? So, but in order to do that, we need to know how far apart these are. So I'm going to kind of cheat. I'm not going to calculate the distance. Instead, I'm just going to check the rate of change. So I'm going 3 across, and I'm going 3 up, right? And yeah, you can calculate the distance and the coordinates. That is just a waste of time in this case of this problem, right? If we want to get this problem right, make it and save ourselves a lot of time and energy, you just check out the rate of change. So we went left 3 and up 3. Okay, well we know we're f staying right where it is because it says with respect to point f. So let's multiply this by 2. So instead of 3, we're going to go 6, right? So we're going to go 3 more, and we're going to go the first 3. That's the first 3, right? And we're going to go 3 more. So 1, 2, 3. And that's where we're going to end up. Hold on. That's going to be our new point. Because now you can tell, look, this is 3 boxes diagonally, this is 3 boxes diagonally, perfect. And it's the same rate of change, same angle, same slope, all that. And this is going to be point, let's see, KL. So K is where E is. Sorry, E became K, so this is K. And now this is L. So when you graph it on the screen, you're just going to graph these 2 points. But the way it's structured is you can drag them. So what I did was I graphed this first, and then I just simply moved this 3 spaces diagonally to stretch it out. So you don't have to there's really almost no advantage to scrap paper on this problem, which is kind of funny. It's like the only one I feel like that's the case. So you're going to plot EF, right? You're going to say, okay, we're multiplying by scale factor 2. That means it has to be twice as large. This is staying right where it is. I'm just going to stretch that out so it's double the size. And I was able to quickly count, okay, 3, that means I'm going to go 6. 3, okay, I'm going 6. Boom, done. You know, if this was scale factor 3, it would be 3 times as large. So it'd be 9, right? It'd be 9 by 9. So, okay, hopefully that clarifies that one. That one was a little weird because of the way it's structured. And I think they'll do one more. Okay. So I have to go get some stuff ready for class. All right, so this is number 10. Again, this is one that, like the circle problem, this is something that probably most students either don't remember, or if they do remember, I think they're gonna have a hard time remembering this one. So again, this is kind of a problem where you want to make sure you pay attention to this example when you're going into the test in case they throw this at us again. All right, so let's check this out. Consider these probabilities of events x and y. The probability of x is 40%, probability of y is 60%. The probability of both x and y happening is 24%, and the probability of x or y is 76%. Okay. Select from the drop-down menus. Okay, so I actually have to get this problem in front of me. I have to get this problem in front of me because I have to see the options they give you for this one. Okay, yeah, so there's 2 choices here, are either going to be independent or dependent. And then they give us 4 options here, right? They give us 0.4 plus 0.6 equals 1 is true. They give us 0.4 times 0.6 equals 0.24 is true. Can you guys see this? Make sure you can see this. Hold on. Yeah, you can see this. Good. The third option they give us is P of x or y equals P of x and y is not true. And then P of x and y equals P of x plus P of y is not true. Okay, so here we go. Yeah, so this is something that you just kind of need to know, and I'm going to give you the rule right here. So here we go. So if you have 2 independent events, you have 2 events rather, P of A and P of B, right? It's just 2 examples I'm going to give you. And if these 2 things multiplied together equals P of A and B. If that's true, so if you take these two probabilities, you multiply them together, and you get the probability of both happening at the same time, then they are independent. Okay? It's that simple. Okay, so if the probability of one times the probability of the other equals the probability of them both happening at the same time, then they are independent. So let's just check our math here. We can just simply figure this out really quickly, right? So let's plug these in. So 4/10 times 6/10, right, is going to be 24/100. So that is, right? And that does equal of the probability of both events happening, right? That's what it is. So guess what? They're independent. So they give us that as an option. Let's see. They're independent because the probability of 4/10 and 6/10 equals 24 is true. So that would be our reason. Okay? A lot of people, the first thing they want to do is add these together and say, oh, it's one, it's that. If they don't know the rule, right? That's probably that is the most chosen option here by students that don't know the rule. So again, if they want to know if these events are independent, you simply multiply the two probabilities together, okay? And if you get the probability of both events happening at the same time, right, then they're independent. That's essentially it. So again, there's no real way to cheat this one. You just have to know this relationship, okay? So yeah. And I think, we're going to stop there. The next video I do will be the multi-part. So hopefully that answers any questions you guys have. Just a quick review. I did a few this one. So again, first one that we did, this is all about similarity. And this is really where scrap paper is really important. Number 6 is function notation. And again, scrap paper was important. Number 7, scrap paper was not important at all. But you have to know the circle equation. So, make sure you study this one, because if the circle equation pops up, you're going to need to know this. And this was being able to interpret a linear function. I think of all the ones we did, I think this should be the easiest one for you. But you have to have a firm understanding of how linear functions work. Number 9 was a weird one where scrap paper was really not going to help you. You just have to understand how to stretch a dilation out. And then the last one, you need to know this kind of this independent variable or independent event relationship that a lot of students forget. So make sure you look at this one. All right, thanks guys.